Hello everyone, welcome back again. If you want 6 to 8 marks in the university examinations like oral examination, online examination or theoretical examination, then you need to watch this video till the end. Because in this video lecture, I will discuss how to determine the RLs, that is the reduced level of number of points on the Earth's surface by using the tachyometric surveying. As we know, tachyometric surveying is rapid and convenient method of determining the horizontal and vertical distances of number of points on the Earth's surface by using the distance and elevation formulae. So, here I will discuss 5 important cases for determining the elevation of point. In the example or in the examination, problem is asked like this: one RL of point is given and you need to determine another RL of point. So, there are 5 important cases in the tachyometric surveying I will discuss in the lecture. So, first case, if angle of elevation is given, if angle of depression is given, if both the angles are given angle of elevation, if both the angles are given angle of depression, or if one angle is given as angle of elevation and another angle is given angle of depression. So, this video is very helpful while you solving the examples on tachyometric surveying, which will definitely give you 6 to 8 marks in the university examinations. So, watch this video till the end, you will get all about the tachyometric surveying. Now, before starting the actual cases of the tachyometric surveying, first of all we should know which are the important formulae we are using to find out the distances and elevation. So, I am going to explain first which are the important formulae in tachyometric surveying we are using. So, the condition is like this: when the leveling staff held vertical and the line of sight is inclined. Now, what is the meaning of this? Now, this is the instrument station and this is the leveling staff. Now, leveling staff is held vertical. Okay, it is held vertical and the line of sight, now this is the central here, okay, and the line of sight is inclined and the staff is vertical. Now, in that case, what is the distance formula and what is the elevation formula? Now, what is the distance? D is the distance between the instrument station and the staff station, and the V is the elevation of central hair reading from a instrument axis. Now, this is the instrument axis. ये जो है ये instrument axis है और यहाँ पे central hair reading होता है vertical staff का. यहाँ से instrument axis से लेके central hair तक का जो distance होता है, vertical distance होता है, उसको हम कहते हैं elevation. उसको हम कहते हैं elevation, and this is what? This is the distance. Okay, this is the distance. Now, what are the formulae we are using? Now, first, now here I am going, here is the distance formula and here is the elevation formula. So, here D is equal to Ks cos square theta plus C cos theta. Note it down. D is equal to Ks cos square theta plus C cos theta, and V is the Ks sin 2 theta upon 2 plus C sin theta. Okay, the condition is vertical staff held vertical and leveling staff and the line of sight is inclined. Now, here the formula Ks cos square theta plus C cos theta, V is equal to Ks sin 2 theta upon 2 plus C sin theta. Now, what is D? As we know, D is the distance from instrument to staff. Okay. Now, K is the multiplying constant. Okay, the value is depending upon the angle, this angle beta. Okay, then now this is a instrument constant. It is depending upon the instrument constant, and the value is lies between 90 to 100. Okay, and the C is additive constant. Okay, then theta becomes the vertical angle, angle of elevation or angle of depression. Okay, and S is the staff intercept. Now, staff intercept means what? This is the upper hair reading and this is the lower hair reading. When we take the difference between the upper hair reading and lower hair reading, we will get the staff intercept. Okay, so staff intercept is very important for finding the distance and elevation. Got it? Now, next important thing is, if the analytic lens is used in the tacheometer, now in the problem if the word is given analytic lens, then in that case the additive constant becomes 0, that is the value of C is 0. Okay, so the above formulae becomes D is equal to Ks cos square theta, because C is the 0, this term will 0, and again in case of elevation this term is 0. Okay, now if the analytic lens is used in the tacheometer, D Ks cos square theta and V is the Ks sin 2 theta upon 2. Now if the vertical angle theta is given equal to 0 degree, then the formula of D becomes Ks plus C. Okay, because cos square 0 is 1, cos theta की वैल्यू cos 0 की वैल्यू क्या होती है 1 होती है. Okay, that's why it becomes Ks plus C, and the elevation V sin theta की वैल्यू 0 होती है. जब 0 पुटअप किया तो 0 होती है, तो डायरेक्टली V is equal to 0 आता है. Got it? So these are the important formulae when the leveling staff is held vertical and the line of sight is inclined. Remember this thing. Now let us see the case number 1. If there is only one instrument station and there is one staff station, and if the angle is angle of elevation, now here plus theta is given. Okay, so theta is angle of elevation. If the benchmark value is given, now here the green line indicates the ground level. Okay, now if P is the instrument station and A is the staff station, now here you can see H is, what is small h? H is the central hair reading from the of the staff, and it is from the ground. Okay, capital H is the staff reading which is measured at benchmark when the vertical angle is 0 degree. Okay, so if the value of benchmark is given in the problem, and if RL of A, that is the reduced level of A, is asking, then which formula you need to use? Here RL of A, I am going to write the formula here. RL of A, now if the RL of benchmark is known to us here, then RL of benchmark plus staff reading, and which is indicated as H plus, now this is the instrument axis and which is continually, it is imaginary and which is at this place. Now V is the elevation. Okay, and we can directly find out by using the formula as we seen in the last minute. So here RL of benchmark plus H plus V minus H. In this way you can calculate if the staff is held vertical and only one instrument station is there, only one staff is there, and if angle of elevation is given, the formula for finding the RL of A becomes RL of benchmark plus staff reading at benchmark plus elevation minus H. Okay, got this? Note it down. Now the next case is, if the angle of depression is given, now here is the benchmark, this is the instrument station at P, and A is the leveling staff, and the angle of depression, now minus theta, is given here, then in that case the elevation is measured from the central axis. Now this is the axis of theodolite or tacheometer, and the elevation is measured from vertical distance between the instrument axis to the central hair reading. So here if we need to find RL of A, for RL of A, when the angle of depression is given, RL of A is equal to RL of benchmark. Now RL of benchmark, if we know, अगर हमें ये पता होता है RL of benchmark plus staff reading, that is H, okay, minus V, that is the elevation at A, okay, minus H. Now if the RL of benchmark is given in the problem, staff reading we can make the 0 degree angle at this tacheometer, and or if the instrument height is given in the problem, then you can directly measure RL of P plus instrument height minus V minus H. So here for angle of depression the sign of V is minus, and in that in the case of angle of elevation, the sign was positive. Okay, remember this thing. Now next case, case number 3, if both the angles are given angle of elevation. Now here P is the one instrument station, A is the one staff station, and B is the another staff station, and both staffs at higher level, and then if we use or if we make the both the angles angle of elevation. अब यहाँ पे आपको देख रहा है कि प्लस थीटा ए, दैट मीन्स प्लस थीटा ए मीन्स व्हाट, ए को उसने बाइसेक्ट किया है और यहाँ पे एंगल प्लस है. अगर ये ए भी क्या है, बी को बाइसेक्ट किया है और यहाँ पे प्लस थीटा बी है, मतलब एंगल ऑफ एलिवेशन है. ठीक है. सो हियर दिस वर्टिक हॉरिजॉन्टल लाइन रेड कलर में जो दिख रही है आपको, दिस इज द इंस्ट्रूमेंट एक्सिस. सो व्हाट इज the elevation measured we from the axis of the theodolite up to the central hair reading. So here I can make the theta A, theta B. Okay, and then if we know अगर यहाँ पे RL of A दिया गया है, अगर इस केस में अगर RL of A दिया गया होता और RL of B पूछा गया होता, तो you will find how to find the RL of B. सो यहाँ पे केस में लिखता हूँ, इफ़ RL ऑफ A इज़ नोन, अगर RL ऑफ A नोन होती है, देन RL ऑफ B, अब ये RL ऑफ B कैसे होगी, RL ऑफ A, अब यहाँ से इसको हम ऐड करेंगे प्लस सेंट्रल हेयर रीडिंग H एट A, यहाँ से जो हमने देखा सेंट्रल रीडिंग, माइनस VA, हम क्या करेंगे, एलिवेशन को यहाँ से माइनस करेंगे, माइनस VA. क्यों किया ऐसा, क्योंकि हमने डायरेक्टली एक कॉमन जो लाइन है इसकी एलिवेशन हमें डिटरमाइन करनी होती है, इसलिए हमने ये किया. एलिवेशन ऑफ इंस्ट्रूमेंट एक्सिस यहाँ तक आया, प्लस क्या करेंगे, अब यहाँ पे एलिवेशन एट B की जगह VB है, तो इसको अगर हम ऐड करेंगे और उसको माइनस करेंगे, हमें RL ऑफ B मिलेगी. सो VA प्लस VB माइनस HB. अब ये वाला जो टर्म है HB का हमने क्या किया है, माइनस किया है. गॉट इट. यस एट A, स्टाफ इंटरसेप्ट एट A, स्टाफ इंटरसेप्ट B, वो हम क्या करेंगे, डिस्टेंस और एलिवेशन फॉर्मूले, मतलब V और यहाँ से इसका डिस्टेंस PA और PB फाइंड आउट करने के लिए इस्तेमाल करेंगे. गॉट इट. नाउ इफ RL ऑफ B इज नोन, अगर RL ऑफ B हमको पता होता, ठीक है, देन RL ऑफ A क्या होता, RL ऑफ A क्या होता, सिंपल, RL ऑफ B, अब ये क्या होगा, RL ऑफ B प्लस HB माइनस VB. ओके, अब ये कांस्टेंट यहाँ तक रहेगा, प्लस VA माइनस HA. ओके, समझ में आया. वाइस वर्सा. नाउ द केस इज इफ द बोथ एंगल्स आर गिवन as angle of elevation. Got it everyone? Note it down. Now the next case is if both the angles are given as angle of depression. आप यहाँ पे देख रहे हैं A यहाँ पे स्टाफ स्टेशन है, B सेकंड स्टाफ स्टेशन है, and instrument is directly placed at the center, at the hilly region or at the highest level. Now in that case we can measure the minus theta A by bisecting the staff station at A and minus theta B by bisecting the staff station at B. Okay, so in this case if the RL of A, now here you can see VA is the vertical distance from the instrument axis to the central hair reading at A, VB is the distance, vertical distance between the instrument axis to the central hair reading at A. S at A, that is staff intercept at A, SB staff intercept at B. Okay, similarly HA central hair reading from the ground, HB central hair reading from the ground at B. Okay, now if RL of A is known, then RL of B, how will you find the RL of B? Okay, हमें RL of A दिया गया होगा और RL of B पूछा गया होगा और both the angle of depression होते हैं, vertical angles. Then in this case diagrammatically you can say RL of A RL of A, okay, I will add the central here reading HA, okay, then I will add the vertical elevation VA. Now this give me the height of the instrument axis, okay, and which is common for both the staff stations. So I will take this minus VB and minus HB. Got it? So here RL of B becomes RL of A plus central here reading at A, plus VA, okay, then minus VB minus HB. Okay, got it? Now if RL of B is known, then RL of A becomes, now RL of B is known to us, then RL of A becomes RL of B plus HB, okay, plus VB minus VA minus HA. Okay, so in this way you can calculate the reduced level of both the points by using this terminology. Okay, diagrammatically you can directly find out the RL of B, RL of A. So whenever the problem is given in the exam, first you have to draw the diagram, okay, and with the help of diagram you can directly find out the RLs of both the points. Got it? Now the last case is if one angle is given angle of elevation and other angle is given angle of depression. Okay, most of the time this type of the questions are asked in the examination. So here अब यहाँ पे एक इंस्ट्रूमेंट स्टेशन सेंटर में दिया है या कहीं और दिया है ग्राउंड के ऊपर. अब A पॉइंट जो है लोअर साइड पे है और B पॉइंट हायर साइड पे है. A इज द एट लोअर साइड एंड B इज द at right side. Now as we know, elevation is measured from the central axis of the theodolite or tachyometer. VA is what? Distance between the central axis to the central hair reading. VB, distance between the central axis to the central hair reading. HB, now here what is this? This is H, this is SB. This is SB, staff intercept at B, and this is SA, staff intercept at A. So here distance and elevation we can directly find out by using the formula ks cos square theta plus c cos theta, and elevation ks sin 2 theta upon 2 plus c sin theta. Now here in this case, if RL of A is given, if RL of A is known, अगर RL of A यहाँ पे दिया गया होता, then how will you determine the RL of B? That is challenge. RL of B. Now diagrammatically you can directly say RL of A is given, that's why RL of A plus central hair reading we can measure from the tachyometer HA, okay, plus VA. Now I will get the height of the instrument axis plus VB minus HB. Note it down, it is very important. RL of A plus HA plus VA plus VB minus HB. Okay, now if RL of B is given or B is known, then what is RL of A? What is RL of A? Then if RL of B is given, then RL of B plus HB, that is the central hair reading, HB minus VB, we will get the central axis, height of the central axis or axis of the instrument, minus VA minus HA minus HA. Okay, are you getting the difference between the angle of elevation, when angle of elevation and angle of depression is given, then the formula becomes like this. Okay, so you no need to remember this thing, इसको याद करने की ज़रूरत नहीं है आपको। जब भी एग्ज़ाम में सवालात पूछे जाते हैं तो आपको पहले डायग्राम ड्रॉ करना है रफली, एंड यू हैव टू फाइंड द RL of required RL of the point by using these terms. Got it? So I hope you well understood about all the cases used in the tachyometric surveying, which will definitely useful while you solving the example on it. So share this video to all the civil engineering friends so they can get also benefit of it. If you like this video, please press the like button, and if you are new on this channel, then please subscribe the channel. Okay, so we will meet in the next video with a new topic. Thank you so much.